Okay, this one, pretty similar. Does anybody notice right away what's a little bit different about these two problems than the last two? There's not fractions. We like that part, right? Yeah, on this one, there's a variable on each side. The other one, the variable is always on the left. This time we have variables on both sides. The way you solve those is a little bit different. It's not drastic, but it's a little bit different because you have to get the variables on the same side of the equation. Okay? So some people like to do whatever keeps it positive. Some people like to always go left. Mm, show of hands. Who wants me to make it go left even if that makes the y negative? Okay? Who wants me to go right and keep the y positive? We'll do it that way. All right, so first thing I'm going to do is get the y's on one side. How do I get rid of positive 3y? We're going to subtract 3y. Okay, but I have to do it to both sides. That leaves me with just 5 equals 2y minus 1. Now it's like the problems we just did. You got to get the variable by itself. I'm going to add 1 to both sides. That gives me 2y equals 6. And then that means the 2 is being multiplied by y. If you want to keep in the manner we were doing, you just multiply by the reciprocal. The reciprocal of 2 over 1 is 1 over 2. But some people like to think of it as a division problem, even though it's the exact same thing. The opposite of multiplying by 2 is dividing by 2. And I'm going to do it that way. I'm going to divide both sides by 2. That leaves me with 3 equals y, or some people prefer to write it y equals 3. Same thing, though. That's like the, I don't know, one of those properties they always make you remember, then you forget the next day. Associative or something. I don't know. Y equals 3. 3 equals, let's call it the reflexive property. Maybe it's called the reflexive property. It's called the mirror property. Both sides are equal. You can flip flop them, right? Any questions on that one? All right, then. Why don't you try B?